For this one, it says use n equals 6, p equals 0.4 to complete parts A through D below. So we have a nice table here, discrete distribution, and my instructor tip for part A, you can use the y equals binom PDF npx and the table feature. To do this much easier, look for a video in the homework help, which is what you're doing right now. Do not use the formula. And then you can just use the one that's given in part C for both. You should get the same answer for part B and C. So you don't need to use the formula they give you in parts B. Keep that in mind. Okay, so let's use the calculator. So what do I mean by that? So we could go ahead and do distribution and go to binom PDF, because I'm evaluating individual probabilities, 6.4, and the x in this case, this first one is 0. Press enter, and there it is, and type it in, and then repeat 6 times. Press second enter, and change that to a 1, and press enter. Not too long. Let me show you a slightly easier way, maybe. I'm going to press y equals. I'm going to turn off my stat plot, press enter, come back down. Okay, so I'm going to put distribution, go down to binom PDF, and I'm going to put in 6.4, and for the x value, I'm going to put this xt theta n. I'm going to put x, and you'll see y in a second. Enter. So now I have this in my y equals menu, and I'm going to leverage my table feature. So press second table set just to make sure. We'd be okay if we're on auto, but I like going over here to ask. So scroll over for independent and select ask. Then press second graph for table. And now I can put in my value, 0, enter, 1, 2, 3, 4, 5, 6. Okay, so a very nice way to compute these very quickly. So you just populate these out. So again, we did not have to use the table. Remember, I could go back here and evaluate the binom PDF for each individual one. That doesn't take a lot of time, but I sometimes want to show you ways that are a little more efficient and leveraging some of the functions on the calculator. Let me show you the same thing in StatCrunch. So here we are in StatCrunch, stat, calculators. I'm going to go to binomial. There we are. So n is 6 and p is 0.4. And we can do equals each of those individual numbers. So like there's the first one. I don't know the way currently that I'm thinking of on how to get StatCrunch to do this automatically for you. So you just have to keep just changing each one of these, not too hard, and typing each one of these in. Just changing the value. It'd be nice if they had a way to do that, and they might, and I'm just unaware of it. So I hope that helps. Okay, so for part B, we're just doing n times p to find the mean. So 6 times 0.4 is 2.4. The standard deviation, another formula, is the square root of n times p times q, and q is 1 minus p. So the square root of n times p times 1 minus p. And so we do that and we get 1.2. Do not try to use this formula here. So we're basically using this formula on both of them. They're trying to get you to see that these are equal to each other, but no need. You can trust it. So these are the same. And 1.2. So part D, let me minimize this, says draw a graph of the probability distribution and comment on its shape. So if we look here, 1's at about 0.19, it goes up to 0.3, comes down a little bit, and then drops off sharply. So which one does that? Looks like it's going to be B. Let me go up a little bigger here. Yeah. See, starts here and then comes up and then comes back down. We can also see that we also saw this when we did it. So here was the graph in StatCrunch, very similar. Okay, now let's describe the shape of this. Let me blow it up a little bit more. Okay, so I got a good look at that. Let's see what my choices are. Symmetric, skewed left, bimodal, skewed right. So it's got a touch skew to the right, right? I could definitely go with symmetric on that one though, but I'm guessing they're wanting skewed right. Yes. If you had answered symmetric on my class, that would have been fine. That's not exaggerated enough to be skewed right. It's close enough. Okay, so I hope that helps.